The average American citizen creates around 5 pounds of waste per day. As a nation, we create 1.6 billion pounds of waste on a daily basis. A massive part of that waste being non-biodegradable plastic. We mix that dirty, crushed plastic in with our garbage, throw the bags into bins, and turn a blind eye as our overwhelmed recycling centers attempt to sort out the mess. When they fail, the plastic enters our ecosystems, crumbles into our water and into our food. When the system of recycling succeeds, the plastic can be sorted, sold for a profit, reused, remade, and has a chance to realize its full potential as one of the incredible inventions of our species. Plastic's not the enemy of our future. It's a tool. Our civilization just needs to become better at managing that tool. On this episode, we welcome Amanda Mars of AMP Robotics. AMP Robotics is a company that uses machine vision and machine learning to train custom-built robots that can sort our trash faster and more accurately than has ever been done before. They can see and categorize our trash to any degree of specificity, creating perfectly sorted bales that can easily be sold, remade, or repurposed. This technology could be a pivot point for our civilization as we take step after tiny step towards an economy where everything is reused, where few things are wasted, and where landfills are a relic of an uncertain past. My name is Robert Roach, and this is the Type 1 Planet podcast. Watch or listen to this episode. Please subscribe. Share it with someone who you think could be inspired by this kind of work, and visit us at type1planet.net. Hello and welcome to the Type 1 Planet podcast. I'm Robert Roach, and I'm joined by our guest today, Amanda Mars, who's here to tell us about the innovations of recycling technology being done by a company called AMP Robotics. So Amanda, thank you so much for joining me today.
Nice to be here. Thanks for inviting me.
All right. So Amanda, the mission of Type 1 Planet, we're trying to reimagine what civilization could look like so that we could enter into a long-term sustainable state that's in equilibrium with ourselves, but also with our planetary environment. And a big part of this is the way we use and reuse and dispose of the materials that we build that civilization with. So let's begin with the problem that we're facing today. What is the current state of recycling, both in the United States and in the larger global community?
Love the mission of Type 1. That's amazing and totally aligned to AMP's mission. Our mission is to create a world without waste. And we really believe that technology can enable that. So why a world without waste? Why is this an important problem for us to tackle? Well, we create in developed countries about 5 pounds of waste per person per day. And that has been increasing. That's about doubled since the 1970s. So you can imagine the trajectory will continue to go up as population increases and as we continue to look at the rest of the global supply chain pressures that lead to things being just smaller, lighter, cheaper to make, easier to transport. And there's always a trade-off between, things like light plastics for your blueberries and how that leads to lower transportation emissions, and then the plastic that ends up in the landfill and what that does to our world. So there's just so much out there. And it's just a growing problem, and all of us have to be a part of this solution. And it's not easy. It's not just like, oh, you make this one change and everything's fixed, right? It's multiple changes to get there. So our mission at AMP to create a world without waste, we really look at everything that ends up in a landfill, and we work backwards from there to say, how do we help avoid that from the landfill? And so there's the feel good of the sustainability piece and of knowing that we're making a positive impact on the world. To date, we've picked the equivalent of items that are 100,000 cars off the road, if you want to equate your trash to global greenhouse emissions. So that's pretty cool, and we'll continue to make an impact there. So there's the feel-good part of it, but the other part of the equation that is not so broadly talked about with our recycling industry is just the circular economy. Everything that we produce can turn back into something else. And so, you might look at an aluminum can for your soda and think, great, I got my enjoyment out of this product. You toss it out, but that aluminum becomes another aluminum can indefinitely. And it's actually lower energy intensivity, I made up a word, than mining virgin aluminum. And so there's so many benefits overall, but it really starts with, we're creating a lot of waste. We can keep it out of landfills. It has a place, but we have to go capture it and turn it back into the good commodities that it is.
How much of this buildup in the landfills and the ocean, how much of that is consumer behavior and how much of that is failings in our recycling industry or in our governmental approach to this problem?
It's a little bit of everything. I don't know that there are specific stats, or not ones that I've come across, but we certainly think that the commodity is the commodity. And so no matter where it starts from in applying technology, you can kind of break it down into three parts of the value chain. There's the item that was created, and is it designed for circularity, meaning it can be recovered and it can be, turned into something else. There's the sortation piece, and that's where we really focus. And then there's the offtake piece. How do you actually turn it into something else, and does it have a place to go? And so the great news is, AMP has been around since 2014. We've been developing our technology for a long time now. It's mature. So that middle piece of the sortation is no longer the bottleneck that it used to be. And it's more than just a physical bottleneck. It was an economic bottleneck before, where a cost per pick just made it not really viable to recover these materials. But when you have technology that can perform, faster, more consistently, than the manual sorting that was required previously, you can start to get more recovered, get more purity in what you're recovering, and drive your cost to pick down. So that middle part of sortation, this is the golden age for it. And so now we're looking to how do we really help influence and push us upstream with design for circularity, and then how do we help connect the way that we sort into the offtake downstream.
I'll be really interested to talk to you about the design component. We're big on the kind of, there's a concept called cradle to cradle design principles, and we're actually trying to get the original designer of the cradle to cradle system on the podcast, and he's
Awesome.
interested. We're working on it, but
Great.
okay, Amp Robotics is addressing the consumer behavior,
Yes.
in a sense, because we technically could do this ourselves, meticulously sort into 15 bins everything that we do, but we don't have the time, we don't have the interest, we don't have the incentive. So how those big bags of trash or whatever are getting brought to these facilities, municipal facilities, what's happening to them now, and then what happens when AMP is installed in that facility?
Yeah, awesome. So we'll break down. You put your used item in your blue bin in your curbside program, assuming you have a curbside program in your area, because not all listeners are going to have one, right? And that's a different topic. So assuming you put it in your blue bin, it gets picked up. Everything gets mixed together. So it doesn't really matter if you separate at home, because it's all going in that truck and getting mixed together and crushed and everything. It goes to a location called a material recovery facility, or a MRF. So at that MRF, that truck backs up and it dumps all of the goods that were in that truck onto what's called a tip floor. It's really just like it sounds. It's a giant pile of all the recyclables. It's huge. These piles are just massive when you start to look at the scale of the population that we have. So from the tip pile, the material gets loaded into a whole series of belts and sorts. So typically first there's what's called a pre-sort, and that's removing the items that are not recyclable. There's a term we use in the industry called wish cycling. People wish these things could be recycled, so they throw them in their bin. But what happens when you do that, listeners, is you're actually gunking up the works, and it can break equipment and cause very expensive downtime for these facilities. So things like garden hoses, laptops, or electronic goods with batteries, those actually end up causing fires at these facilities and burning them down. So you really have to look at what your local recycling center is telling you is recyclable, and only put those items in your recycling bin. When in doubt, throw it away rather than recycling it. And I hate saying that, but it just can cause so many issues in the facility. So Christmas lights, not recyclable. Bring this to an electronic recycler, please. Because that's
good to know. Good to know for the upcoming month. Got it.
Exactly. So you go through a pre-sort where you're pulling out, and this is manual at this point, pulling out the big items that once we can see them, pull them out before it gunks up the works. Then it goes through a screen to pull out your big pieces of cardboard. So that's where you start to get what's called 2D and 3D separation. So your papers, your cardboards are going on one stream, and then in a parallel path, your containers, which can include your plastic and your aluminum cans and your cat food cans, and all of those are going in a different stream. Then there's a series of sorts for each of those to really separate it into its different commodity goods. And what those commodity goods are is highly dependent on where that MRF is located and what offtake is in their area. We don't want to be moving this waste from where you are in Connecticut across the country to where I am in Seattle. That just doesn't make sense. That'd be a lot of money and a lot of emissions to move this waste. So it's really all tailored to what's local in the area. So, for example, you might separate your paper into sorted office white paper, which is kind of your printer copier paper, newspaper, or like a mixed craft paper. That might be kind of a common split there. On your containers, we tend to separate into the different plastic polymer types, where you're getting your most valuable plastics separated by their own polymer, and then a mix of the things that are, not as valuable on their own. And then, of course, aluminum cans. I've mentioned them so much already here because they are highly recyclable, highly valuable. So the dollar per ton for them as a commodity good is really, really great. And then just the environmental benefit of any raw earth metal. You want to always recycle your metals. So that tends to be how things are separated. AMP technology comes in at those sort points for either a QC, which is a quality control application. So if you've separated, for example, your sorted off as white paper, but there's some stuff in there that wasn't supposed to be in there. Maybe it's some film, or maybe an aluminum can got in there. Our equipment will come in, will identify, hey, that's not what's supposed to be in this stream, and then pick it out and drop it into a bin that typically goes back into the front of the line to go through its recycling process and hopefully get in its bin. So that's one application, is a quality control application. The other is where we're picking intentionally. So something like what's at the very end of the facility is called a last chance or a residue line. And that's right before things go out to landfill. Let's look and see, is there any good in there? And let's positively pick that good out so that we can recover it. So typically robotic applications are used in place of where humans traditionally have sorted. And this is one of those, issues that all of us across multiple industries face with just a shortage of labor. But I also feel really passionately around how dirty, dangerous, and repetitive sorting can be in these facilities. If you imagine you're working on a line that's moving 100 feet per minute, and you're repetitively doing a picking and throwing motion, and then all of a sudden a cat food lid comes down that's kind of sharp and cuts your hand. And of course you're wearing PPE, but it's a very dirty and dangerous and repetitive role. So that's where robots are just perfectly designed to be able to fit in those locations.
Just to bring it back for a second. So it sounds like the value of polymers and aluminum comes from their recyclability, their reusability.
Absolutely.
And so you're actually creating, I think you call them bales,
Yeah.
of substance from this process that can be resold. Is that right?
That's right. Yeah. So I guess I kind of left that out of my overview of a MRF. So once we sort everything, it goes into bunkers, so holding areas. When you accumulate enough of that material, it'll go to a baling line. So it's just a conveyor belt that moves everything to a baling machine that'll just compact everything down, make it into this really dense cube of that commodity, tie it up, ship it out. And that's how things are recycled, folks.
And who's buying aluminum, for example?
Yeah, so the folks who are going to take it and turn it back
Mm-hmm.
into aluminum.
Okay, got it. So
Yeah.
maybe a can manufacturer. Okay,
Yes.
got it.
Yeah.
Got it.
Yeah.
So let's talk about the actual action. You talked about the robot grabbing the item off of the belt there, but what's happening when it's doing that?
Yeah.
What's the robot doing, and how is it doing it? What are the names, the words that are associated with that action?
Yeah, awesome. Get ready for some technical deep dive here. So
We're ready.
we have computer vision, so artificial intelligence using cameras. So the same as humans can see, you can teach a computer to see in that way too, using just a normal RGB camera. So we have a camera mounted over the belt, lighting around it, because you have to have a really consistent lighting condition for cameras to be able to see and interpret things. And we have gone through training on these images. We have billions of images from our installed base all across the world, and we're constantly training on it to be able to identify what those images are. So you take a 2D image from a camera, just like a human can see it. And if you can train a human to interpret it, you can train computers to interpret it. And so we're identifying, oh, hey, that's an aluminum can. And then based on the settings that we've input with the customer on what they're trying to recover, we have a whole bunch of different settings on, well, do you want it to be really pure? Like, how sure that this is an aluminum can that you want us to be? Everything with AI has what's called precision and recall. So how sure do you want us to be? Or is it okay if we're not too sure and you just want to recover as much as possible, even if that means that we might sometimes pick up something that isn't actually an aluminum can, as that example. Um, all that then goes into the pick command to our robot. So we've written our software to control the robot that allows for different optimizations, making sure we have the fastest path to go after the item, the best optimized grip success for the item. Are we picking it in the right way? Are we picking at the right place? Are we moving it in the best way possible to its bunker location? So lots of settings that go on for the robot to be able to say, hey, can we get there at the right time? And can we go get it? Can we, successfully get that object? And then the robot uses that command, goes, picks it up. We use what's called a Delta style robot, which is just kind of, if you think about many arms, but in a V. With a gripper at the bottom of it. And the nice thing about recyclable materials is we don't really have to keep them in a perfect form factor. They're already crushed and dirty and torn and, smushed from the whole process. So we can just punch down on the item, get a really good air suction grip with our cup. It's a collapsible gripper.
Mm.
Get a good suction grip, pick it up, move it, and then blow it off at the location where it needs to get dropped.
Wow. Okay. So we've got the belt coming down. We've got a Starbucks cup
Yeah,
that's crushed up. Maybe I hear that you can make a bin just for Starbucks cups if you want.
sure.
And so just a standard camera will see it. The program on the back end will look at the video and say, ah, that's a Starbucks cup
Yeah,
right there. It looks like that surface right on the logo. That's the perfect spot to throw down the the
exactly.
suction cup, and the arm will go there quickly, grab it, and then toss it in the bin. Um, that's brilliant. And how many times a minute could these devices do this?
Yeah, about 80 picks per minute. And there's some applications where we can go faster. Depending on the gripper setup, we can actually put two grippers, so up to 120 picks per minute in that setting. We
Wow.
also have what's called a tandem robot, where if you have a wider belt, you can put two robots kind of offset from each other on the path of the belt so that you're getting the whole belt width. So in that case, it's one unit, but two robot picking arms. So you
Mm.
get even faster pick rates.
Wow. Okay.
Yeah,
Now the you said that the machine learning is actually being implemented as it's being utilized. So it's the technology itself is improving over time.
absolutely.
Did you say that all the recycling sites are actually communicating data with each other to holistically improve the entire technology?
Yeah, so we care about latency in this AI application. So, for those of you who may not be aware of AI, you have to have the ability to do that interpretation out on the edge, meaning where the equipment is located. You want it to be able to make up its mind really quickly with the rules it already knows. So, we're handling that in real time out on the edge because you only have about, I don't know, a couple feet of belt width before your object gets to the picker. And so that's translated into a millisecond of latency time in between. So we do all of the pick commands and the inference on the edge, but we're sending all of the images back to the cloud where we're doing training. So if you imagine, we have 250 or more. Every time I say that number, we install another robot and it keeps going up. So we have, all those installations in the world sending us the data. And then in the cloud, we're constantly doing neural network training. And that's what the neural network piece is that, all of it is coming back up. And then on a regular basis, a few times a year, we will update our neural network and push it down to the fleet. So now at the edge, that brain has gotten smarter.
Wow. So, I mean, I'm thinking about now how the relationship with the facility actually works. You have employees; they're not AMP robotics employees; they're municipal recovery. What was the word again that you used? MRFs.
MRFs. Yep.
Okay, nice. Municipal recovery facilities, right?
Yep.
Uh, how does that relationship pan out? Did they buy the technology? Are you leasing it? What are the costs of doing this? To the
Yeah.
whole system.
Yeah, so typically in this industry, like most big industrial equipment facilities, the owner of the facility will own the assets in the facility. It just, lots of reasons for that, but that's, typically the model for it. So what has really helped with the adoption of this technology is these facility owners have had trouble finding sort labor. To fill the spots and to recover these materials. The trash or the waste, I should say, doesn't ever stop. It keeps coming every day. But if you have folks who are not showing up to work or they just really don't want to do that job, it doesn't smell great in these facilities, right? Dirty, dangerous, repetitive work. That's where these facility operators have said, we've got to do something different. And so this technology has really helped solve a recoverability problem for these facility owners because they just couldn't get people, to show up to work to sort this.
And you obviously are coming to them with a value proposition too. You're saying you're going to, the recycling that you're going to get, these bales are going to be much more valuable. Is
Absolutely.
there any metrics on how much more valuable,
Yeah, I should probably pull some data and throw together a couple of metrics, but we break it down into you can recover more if you look at a pick per minute basis. The robots can perform usually 2 to 3 times faster than a human can. So within a minute, you're getting 2 to 3 times more material than a human could sort. So there's just pure volume as part of the increased revenue, but there's also because of the quick decision making that a computer can have that us humans are a little bit slower at it, especially, I've got other things on my mind. I'm a little tired today. I need another cup of coffee, right? I might have a little bit of a lapse in my decision making. And AI can also see things that humans just can't. For example, we've seen with two types of metals that look very similar, both just kind of shiny silver metals, the fracture pattern on the edge will be different. And AI picked up on that before we did. And we went, oh my gosh, that's incredible that it learned to do that. Just from enough examples, it saw what the pattern was. So that's the sort of benefit where you can get a purity increase in that bale as well. And so that's the second revenue boost. So you get more material, you're getting more pure bale, which has a higher price in the market. And then your cost per pick is lower than what you'd have to pay for manual sorting. So just
Got
makes
it. So
this margin, right? You get the revenue up, you get the cost down, your margins get bigger.
a privately owned MRF with AMP robotic technology potentially could be making 3 times more profit from what they're bringing in than
Yeah,
the alternative.
potentially. Yeah, all these
Okay,
commodities have a different value, so it's a little hard for me to give
sure.
an exact number to it. But yeah, potentially.
And these facilities, they're not. I thought of them as being owned and operated by local governments. Is that usually not the case?
Usually private.
Oh wow. Okay. There's there's an amazing. I'm thinking ahead. Like there's an amazing service here in Connecticut called Butterfly with 2 Ds, and it's basically an energy efficiency as a service model
Mm,
where it's a for-profit company. They install energy efficient technology into businesses for free, and then that company that they've installed it into makes energy savings,
yeah.
and Butterfly takes a percentage as profit, and they're like making hundreds of millions of dollars from this model, and it's working beautifully, and everyone's using less energy and all that stuff. It just I wonder if the model could be applied here. I'll have to talk to the CEO of that company. Maybe we can work something out. That's a fun
Yeah.
idea.
Yeah, potentially. Typically, what we see is industrial equipment facilities want to own their equipment. There's, financial reasons like being able to depreciate assets, but there's also just having everything in your facility that's under your management and you can move around and just makes a difference in some of the terms for it. But we have seen that there are some requests for different financing kind of plans, like a robot as a service, where you're really paying more for a pick.
Yeah.
Rather than like a difference of what you would have had before. So a little different from the energy world. I used to work in energy and smart
Oh,
grid
cool.
myself. And so you really look at a really fun term I love from that is negawatts, where instead of
Ooh.
megawatts, it's negative megawatts, where you're
Oh,
trying
I
to
love that.
avoid energy usage, especially if you think about like a really hot summer day and peak demand. But anyway, now we're not talking about recycling. We're talking about energy, which is another topic I love.
That's
But
all
I
right.
do think that there's some, similarities. What it's all about is just how, in both cases, the sustainability pieces, how do we drive down consumption? How do we, make it more cost effective for what we're trying to deliver?
Well, I think that's a big part of this show is cross pollinating good concepts and good ideas. And so it's definitely interesting to hear about this model. And it sounds like it's working. Are you seeing a rapid uptick in terms of popularity of implementation for municipal facilities? Is it are you having any exponential curve kind of situation
Yeah.
happening?
Yeah, so there's a couple of kind of external factors in the industry right now. So for sure, all the time, right? You've got those commodities coming in, you want to be able to recover them. But there's also some government policy with things like extended producer responsibility that is already in Europe because they don't have as much landfill space, so their recycle rates have always been higher out of necessity than someplace like the U.S. where I'm located. But even in the US, we are increasingly seeing more and more states look at and adopt extended producer responsibility schemes, which really is saying that the creator of the packaging is responsible for the recovery of it. Well, in practicality, that doesn't mean your soda manufacturer is going to run trucks around to go pick up their cans. That's not practical. That's not energy efficient. It's not cost effective. What it does mean is that we can use this technology with our vision systems across the facility to count what are we seeing come in. And does it fit that packaging category? And so it really becomes a data gathering and reporting exercise that helps connect the dots across the system. So when I talked about those, three components of designing for circularity, sortation, and offtake, data is really the connection point of what do we see happening, and how do we use that data to drive intelligent decisions on how to make it, better overall for the whole system.
This conversation wouldn't be possible without this technology, in
Yes.
many ways. So are you using that data to influence and promote changes in governmental policy? Are you meeting with governments? Okay.
Absolutely, absolutely. And what has historically been done is manual audits, where you take a small sample set of the data and you go through a very intensive, manual sorting process to try to, put those materials into different categories and then count and report. You can imagine it's very expensive, but it's also prone to human error. Not that machines don't have error, but it's just, different and lower than human error. And so that's where this technology, we're not having to do a small sample with a manual audit. We're doing, all the time samples. So it's pretty cool just to get the volume of data that we didn't have before.
Okay. Now,
Yeah.
I want to take us a little bit, or big picture. Let's start with another big topic that we're interested in over here is oceanic trash and recovery and sorting. And just, wanted to see if there's ever any conversations on your end. I think it's governments that are actually collecting that trash, and they're not quite, there's not really a good plan for how it's being recycled or where it's being deposited and that kind of stuff. Have you ever thought about what's happening in our oceans, and are there any kind of plans in terms of this technology making into that space?
Yeah. No, but I'll definitely put that on our product backlog to look at, like little submarine sortation. That'd be really fun.
Oh my God. I have this vision of like giant barges picking up all of our trash in the ocean and just automatically sorting it, and selling it to companies and, or
That'd
selling it
be
to
amazing.
countries. Yeah. Um,
That'd be amazing. What we're
yeah.
really focused on is keeping that from even entering the waste stream that then
Yeah.
becomes, part of the ocean. And let's just make sure that we're, at the point of collection, and let's sort it and make it just not even get to that point.
Right. So
Yeah.
let's talk big picture. What does the modern global ecosystem look like if this technology is holistically implemented in recycling sites around the world? What does a perfect recycling stream actually look like? And you've been talking about a little bit in terms of the design and,
Yeah.
the speed of technological improvement, but,
Yeah.
what's the grand vision here?
Yeah, my North Star vision, and I think we're closer than we used to be, but we still have a ways to go. Is that every package starts with being designed for circularity? It's either designed for compostability or recoverability. It all has some place it can go. And then the next part of, so that's kind of that first part, right? Everything is designed to be able to end up in another state that's a good state for the world. Within sortation, then my North Star vision is that just that we're able to, take anything that we can get and sort it into its appropriate like place that it needs to go. And then there's so much cool research happening at universities and with large think tanks like the Remade Institute around what do you do with this offtake and how do we make everything really, have a home to connect those dots of that design for circularity with, okay, but what is that offtake and what does circularity mean then? So I just envision this future world where nothing needs to go to a landfill.
Mm.
Everything is really designed with this kind of recoverability in mind.
It really seems like an organic ecosystem when you consider it in that way.
Yeah.
And that materials like people don't understand that polymers and aluminum and similar materials, they can be broken down if done correctly, countless times and
Yeah.
remade with almost no, excess. So it would be really interesting to see how that technology improves and if it can keep up with what you guys are doing in terms of machine learning.
Yeah, exactly. So one of the other ways that we imagine the future is that making it just so efficient and effective to recover material. So one of the steps that we've made in the short term to get there is what's called a secondary sort facility. So we've taken our AI and our sort capabilities, we've designed a whole facility end to end. We actually have 3 of these facilities in the US. And so we've taken what's in the residue stream from other primary material recovery facilities. And so said, hey, you were about to throw that out, or hey, that's your mixed plastics and you don't have an offtake for it. Let us go through it and mine those commodities one more time using a series of sorts in this, end-to-end designed facility that is all able to use, our technology to drive the sortation process and recover those commodities out of it. So we like to think about it as, one more sort before everything ends up in a landfill, and let's make sure that we're really minimizing what goes there. So it's been really cool for us to, operate these secondary sort facilities, because we're also learning so much about what's left in these material streams, how we can improve, recoverability everywhere in the ecosystem, everywhere, right? We don't want to leave any piece of commodity left behind.
Are you reselling the bales
Yeah.
yourselves and making
Yeah.
a profit in that way too? Oh, that's
Yeah.
fantastic.
Yeah.
So you're taking what everyone doesn't want and making money and new data and improvements on the technology.
Yeah. Yeah. I like to call our commodity bales money cubes.
Ooh, that's good marketing right there. See, people want money cubes for
Money
sure.
cubes.
So, it's wow. And is the cost of the technology going down? Are you able to kind of make these robots for cheaper and cheaper?
Yeah, exactly. And that's part of the really cool thing about designing and operating our own facility end to end, that we're able to really control a lot of that and then play with some really cool things like, well, how do we get the different parts of the system to in real time talk to each other and optimize? And so that's all, things that we're able to really experiment with and then bring it out to the world.
Ooh, so
Yeah.
are you thinking maybe you could make this into I don't know, like a bit of a chain itself, building these facilities everywhere, selling them to governments or to other private owners or something, franchisees,
Yeah.
maybe?
Franchise waste sorting. We hadn't thought about that specifically, but we are just always looking at how do we build the tech that keeps every piece of waste out of the landfill.
I love this. We need to find solutions as a civilization that work in the capitalist system, that are dynamic and make people excited, make wealth and improve the environment at the same time. So this is absolutely wonderful. Before you go, I'm cognizant of your time and this has just been amazing. You mentioned the Remade Institute. If you were able to sit down with a group of people and just talk recycling and just talk about like what are the coolest ideas, how a collaborative session, a debate, what are other companies, individuals, technologies that you would want to kind of learn about or discuss?
Yeah. So for me, because I spend my time thinking about that middle piece of the sortation really goes to what is that offtake piece. And so we're fortunate we do get the chance to sit down with these different think tanks and academic professionals and talk about what what we can sort and to what level, and let's do analysis and we sort things. They do studies on it. So we've got a couple government grants that help with some of that right now, and that's pretty fun work. But it's been really encouraging to me as well. Some large consumer packaged goods companies, and I can't say who publicly, but they've come to us to help train our AI and look at the recoverability of their material, so they can figure out how do they make sure that it's getting recovered and it's not ending up in oceans. And so it's just been really encouraging to me that it's not just this public speech about environmental concerns and corporate sustainability goals. There's action from large companies behind it. And I'm really encouraged to keep sitting down at the table with them and keep figuring it out together, because I think we have some capabilities that, are just further along than they were 5 years ago. And so it's some cool things we can do with it now.
That's awesome. Amanda, thank you for your time. It's super refreshing to talk to someone who's so eloquent. And so, I just want to see you, speaking in front of the world in a couple of years after AMP is implemented all over the continent. So
Well,
thank you. And I'll be in touch. Hopefully we can maybe do another collaborative session or something and keep learning.
That sounds great. And listeners, thank you so much for thinking about your waste today. And if I can leave you with one piece of advice, please look at your specific waste stream and look at ways that you can make sure things are getting into the right recovery stream, even if it means things like going to an electronic scrap recycler to drop some things off. It's worth it, especially your metals, your electronics. Those have a lot of value, and please do make the effort to recycle those.
It doesn't take a lot of work.
Yep.
No Christmas lights in the recycling, y'all.
Please no.
Come on. That's awesome. Well, Amanda, thank you. And
thank you.
Have a great day.
You too.